With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The elements of group 1 describe more clearly than any other group of elements the effect of increasing the size of atoms or ions on physical and chemical properties. The chemical and physical properties of elements are closely related to their electronic configuration, electronic structures, and sizes. These metals are highly electropositive and thus form very strong bases and have quite stable oxo-salts. In the manufacturing of sodium hydroxide, chlorine, and sodium carbonate, the sodium chloride is used as starting material. Which of the following is not correctly matched? So here we have to pay attention to the not, okay? Which of the following is not correctly matched? Basic strength of oxides: CS2O, Rb2O, K2O, Na2O, Li2O. Okay, let us see. Now, first of all, one point that I would like to make clear is whenever we are talking about bases in chemistry in context of JEE Mains or JEE Advanced, as that is our target, the purpose of talking about bases in JEE Mains or other competitive examinations at our level is that we are only talking about Lewis bases. Okay, we are only talking about Lewis bases. Now, what are Lewis bases? I hope you all know it. Still, I'll write it. Lewis bases. What are Lewis bases? So bases which have a tendency to donate electron easily, right? Bases which have tendency to flourish electrons. Okay, so that means when we are talking about CS2O, Rb2O, K2O, Na2O, Li2O, so we have to look at them from the perspective of Lewis bases, right? So the basic character of any substance, like the basic character of any substance is directly proportional to ease of donating electrons, right? Ease of donating electrons. Okay, and now we also know that quite clearly that the tendency of donating electrons is called electropositivity. Okay, therefore we can conclude that the basic character of oxides of group 1 elements is directly proportional to the electropositive nature of central atom, right? And now all we have to do is just figure out the trend of electropositivity of the central atom. The trend is quite simple because electropositivity is directly proportional to the size of central atom. Okay, so as the size increases, electropositivity also increases, right? Why? The reason is simple. As the size of the atom increases, the ease with which the valence electron can be lost also increases. The ease increases. Why? As the size increases, the distance between the valence electron and the nucleus increases, and therefore the atom can lose electron quite easily. Therefore, as we go down the group, and we already know that for group 1 elements, as we go down the group, that is lithium, sodium, potassium, rubidium and cesium, as we go down the group, size of atom increases. We all know that. And as size of atom increases, this implies that electropositivity increases. This implies that basic character of oxide increases. Therefore, the most basic oxide would be CS2O, and the least basic oxide, most basic oxide is CS2O, least basic oxide is Li2O. Therefore, the order given in this option is actually wrong, but we had to find out the incorrect order because which is not correctly matched. Therefore, one of the answers must be this. One of the answers is option number 1 because this is not correctly matched. Now let us see the stability of peroxides. Okay. To calculate the stability of peroxides, the concept that we are going to use is larger anions form stable compounds with larger cations. What is the concept? I will write it down for you. Okay. Larger cations form stable compounds with larger anions. Right. So as we know that the structure of peroxide ion is like this. And there is a bond, right? And also there is a -2 charge. So this is a pretty big anion, right? So as the size of the cation increases, the stability of the peroxide bond also increases, because we already know the concept that larger cations form stable compound with larger anions. So in case of these peroxides, if we look carefully, then we have sodium, we have potassium, we have rubidium, and we have cesium. And we know that cesium has the largest cationic size and sodium has the smallest cationic size, and O2 minus, that is the peroxide ion itself, is a large anion. Therefore, when it combines or forms a compound with a large cation, the compound would be more stable. Therefore, CS2O2 would be the most stable and Na2O2 would be the least stable. Therefore, this order given in this option is correct, and therefore this cannot be our answer according to the question. Let's go to the third option, that is stability of bicarbonates. When we talk about stability of bicarbonates, we have to talk about lattice enthalpy. Okay. Now, a very important point that we must keep in mind while talking about lattice enthalpy is the most important concept for lattice enthalpy is lattice enthalpy. This concept will work for every question at JEE Mains or JEE Advanced level. The concept is, if the cation is kept fixed, if the cation is kept fixed, then if size of anion increases, lattice enthalpy decreases. And if anion is kept fixed, if anion is kept fixed, then in that case, if size of cation increases, lattice enthalpy also increases. Okay, this is the main concept that we have to use. Now let's see the options. In options we have LiHCO3, NaHCO3, KHCO3, RbHCO3 and CSHCO3. Okay, so we have to check the stability of bicarbonates, that is the thermal stability of bicarbonates. Whenever we talk about carbonates, bicarbonates, etc., we always talk about thermal stability. Okay, so as we can see here, the anionic part is fixed, HCO3 minus, this is fixed. So we will go to the point where anion is kept fixed. So as anion is kept fixed, if size of cation increases, lattice enthalpy increases. And we know that thermal stability of any compound is directly proportional to the lattice enthalpy. That is, if the thermal stability is low, then the lattice enthalpy was low, or if the lattice enthalpy is low, then the thermal stability will be low. Okay, so here we can see that the anion is fixed, and as the size of cation increases, that is CS plus has the largest size and Li plus has the smallest size. Therefore CSHCO3 would be the most stable as its lattice enthalpy is the highest, whereas LiHCO3 would be the least stable as its lattice enthalpy is the lowest. And therefore this order given in this option is correct. Therefore this cannot be our answer as well, because we have to find those options that are not correctly matched. Okay, now let's go to the fourth option, melting point. Again we have to talk about melting point. We again have to talk about thermal stability only. Okay, and I already discussed that for thermal stability we have to talk about lattice enthalpy. However, in this case you will observe that the cation is fixed. Okay, the cation is fixed. It is misprinting. It should be like this. There's a misprinting in the question, please pardon that. And now here the cation is fixed. Okay, so let's go to the point. If the cation is kept fixed, then if the size of anion increases, lattice enthalpy decreases. So the size of anion, now we here have F minus, Cl minus, Br minus and I minus. As we go down the group, the size increases, right? So here I minus is the largest anion and F minus is the smallest anion, and as cation is kept fixed, size of anion, if it increases, then lattice enthalpy decreases. Therefore the size of anion increases, then lattice enthalpy decreases, and as lattice enthalpy decreases, melting point also decreases. Therefore in this case NaI should have the lowest melting point, whereas NaF should have the highest melting point, highest and lowest. However in the option it's given just opposite. Therefore as it's given just opposite, this will be our answer. Therefore not correctly matched. So option 1 and option 4 are not correctly matched. So this will be our answer. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.